Hello and welcome back to the Cracking FAANG YouTube channel. Today we are solving Leetcode problem 249, group shifted strings. We can shift a string by shifting each of its letters to its successive letter. For example, ABC can be shifted to BCD. We can keep shifting the string to form a sequence. For example, we can keep shifting ABC to form the sequence ABC, BCD, XYZ. Given an array of strings, group all strings that belong to the same shifting sequence. You may return the answer in any order. Okay, that's the question prompt. We're not going to bother going over the example because this problem is so horribly written, and it's one of those questions that is a zero intuition problem and a 100% memorization problem. If you've never seen this before, you probably won't figure it out because of how terribly this question is written, and this is just one that you memorize, and I guess you just need to be able to explain it. So what this problem doesn't tell you is that characters will actually wrap around. So as you can see here, the characters A and Z are actually in the same shifting sequence. That one's pretty self-explanatory because they're the same character. You know, you can shift A one character at a time to get Z. But A, Z, and BA are also the same because if you shifted both of these by one, you'd get the B here, and then the Z would actually wrap around to A. So that's one thing they don't tell you, but you get wraparounds. Anyway, yeah, the way that you solve this problem is actually really stupid. So what you want to do is, you'll see for each one of the characters here, let's take this sequence, for example, ABC, BCD, XYZ. It's pretty easy to visually see that ABC can just turn into BCD by shifting each one of these by one, and then so on and so forth, and you can eventually get to XYZ if you just shift each one by one. The pattern we actually want to notice here, and the way that you're actually going to solve this, is that the difference in character position of each of the characters between each one is going to be a constant 1. The difference between B and A in the alphabet is a position of 1. The difference between C and B is also a position of 1. Same thing for BCD. C minus D in the alphabet, C minus B is a position of 1, and D minus C is a position of 1. So what you want to do here is, for every single one of these problems, you want to figure out what the shifting sequence is. And what we mean by that is the difference between a character and the next character in the alphabet. Now, we have to worry about wrapping around, but we'll handle that later by using the modulo operator. So modulo 26 to handle the case where we could have something like, I don't know, Z minus B or something, right? We could have like A minus Z, something like that, where we get a negative number. So we want to handle that. But anyway, let's not get ahead of ourselves. What we want to do is we want to iterate over all the strings from left to right. And we want to build a map where the key is the sequence and the value is a list of all the words that fall into that sequence. So this will be words. For example, let's take ACEF, right? ACEF. So the difference, so we're going to build a key out of what the sequence is here. So the first item in our key, and we're going to use a list here because we need to append to it, so we can't use a string and we can't use a tuple because obviously those are immutable. So the difference between A and C in the alphabet is going to be what? 2, right? So the first element in our key is going to be 2. Then what's the difference between E and C? So let's count it out. We have A, B, C, D, E, F. Actually, that's all we need for this problem. So again, it's 2. So the second difference is 2. And the same thing between E and F is going to be 2. So our key is actually 2, 2, 2. Now, if you know anything about data structures, you actually can't put a list as a key in a dictionary because the list is mutable. So we have to turn this into a tuple to basically use it. So for example, in our map here, we would get the key 2, 2, 2, and this would contain the word A, C, E, F. And basically, we'll do this for every single character here. There's a special case if you get a character of length 1, that just belongs to a special count. Obviously, there is no difference, so we'll just put it as -1 here if it's a single character. So we'll just put A and Z in here. And we can basically do this for all the characters. So let's do another example. So we have A, B, C. The key here would be what's B minus A? That's 1. What's C minus B? That's 1. So for the key 1, 1, we will essentially put, let's see, A, B, C. We can do the same for B, C, D. So we'll have, what's the difference between B and C? 1. What's the difference between D and C? 1. So now we have the same key, so we can add B, C, D, and it's the same for X, Y, and Z. And then for this case, this is the point where we actually need to handle our difference. And because if we try to compare A and Z, obviously A is index 0 for characters, or it's maybe 1, it doesn't matter. And then Z is 26, so this will be negative 26. So obviously we don't want to work with negative numbers. Because this wraps around, we actually just want to put, oops, you can't see that, that's outside of the bounds. When we have a negative case like this, we actually just do modulo 26, and that will solve it for us to handle the wraparound. And then these two will get put together. So that is the general intuition. Kind of just to summarize, we're going to go over the strings from left to right, iterating over each of them. We want to build a map which maps the sequence to each of the words in that sequence. And the way that we derive the sequence is we take each word and we compare a character starting from the first index with the last character before it, and we take the difference between the characters in the English language, right? So the position of C minus A is going to be 2, right? Because C is the third character, A is the first character, so 2. And we're going to do this successively until we build our sequence. This is going to be a list. We need to make it into a tuple to put it into our dictionary, and then we're going to insert that key, that word for that key, and then at the end, all we need to do is just return all of the values here from our dictionary, and that will actually give us our answer here. So, very strange problem. Like I said, if you don't see the solution before, probably not going to come up with this one, especially because they don't tell you anything about wrapping around in this question. But anyway, that's enough blabbing. Let's actually go to the code editor and type it up. The code is surprisingly simple. It's just figuring out what to do from this shit problem description. That's the hard part. So let's code it up. All right, we went over the intuition and saw how stupid this question is and how you probably won't figure it out unless you see the solution. Now let's actually code it up. And luckily, it's really easy to remember the solution and explain it. So hopefully, once you've kind of seen it once, then you never have to worry about this problem again. It's just one of those questions. So remember that we want to build a map which maps the sequence to all the words that follow that sequence. So we're going to need to define our data structure here. So let's call it our grouping dictionary, and this is going to be collections.defaultDict, and it's going to be a list. So we can just append straight to that key. We don't have to do checks if it exists, blah, blah, blah. Okay, so remember that we now want to iterate over string in strings and basically build that sequence and append it to our grouping dictionary. So we're going to say for string in strings. What we're going to do is we're going to say if the length of the string actually equals 1. Remember, this is a special case. Obviously, there's no character for us to look before because it's obviously length 1. So this is a special case. We're going to say that grouping dict for this one is simply going to be a tuple with the key -1, and that's all for that one. And obviously for that key, we just want to append our current string. Okay, otherwise, we need to compute those differences in the characters. So we need a list to store those differences. So we're going to say char diffs is just going to be an empty list. And then we want to go over our string from left to right. And we want to get the index because we need to compare to the previous index. So we're going to say I equals 1. The reason we do I equals 1 is because we're going to be looking back here. And obviously, if we started at 0, then, well, in Python, you just go to the back of the string, but that's not what we want to do. So we have to do I equals 1. So we're going to say while I is less than the length of our current string, what we're going to do now is we're going to say that we're going to append to char diffs what? Remember that we want to append the difference between the two strings, right? So we're going to say ord string of I. So what the ord function does is basically given a string, it will give you kind of the position of that string in the alphabet. And well, it's in the ASCII table or something, but basically, you know, if you give it A, I think it'll give you either 0 or 1. If you give it B, you'll get either 1 or 2, depending on whether it starts there, but you get the idea. So we want to do the difference between our current character, and I actually have to make sure I don't mess up the parentheses here because it's actually important we get these right. Okay, so that's the closing parenthesis for that one. So we want to do the difference between the ord of our current string and the ord of the previous index in our string. Shoot, that should not be a parentheses, that should be a bracket. Okay, ord -1. These two will close each other. I think I'm missing one. No, okay, what is this closed? Okay, this should be closing it. Okay, cool, and then we want to just take the modulo 26. And the reason we do modulo 26 is because we want to actually get rid of negatives when they happen. So we don't want to deal with the negatives. We want for it to wrap around, and that's why we do modulo 26. 26, obviously, there's 26 English lowercase characters. Okay, so now what we want to do is once we've appended that, obviously we want to move on to the next thing in our string here. So we move forward. And then once the while loop ends, we simply just want to add our character differences as the key and add whatever word we were just parsing. So we're going to say our grouping dictionary. We're going to, as the key, remember we need to set it as a tuple because you cannot have lists which are mutable as dictionary keys. It needs to be an immutable data structure. So that's why we're going to pass in a tuple of our char diffs, and then we're going to append our string here. And that's all we need to do. At the end, we remember that the mapping is from, we're going to have a mapping of the key to basically the list of words for that key, for that shifting sequence. And then our solution is already a list of lists, so we just need to return the values from our dictionary. So we're simply going to say return grouping dict dot values. Okay, let me just make sure I didn't make any mistakes because this parentheses thing is definitely going to mess me up. Okay, cool. Looks like I got it. That is surprising. And once we submit this, it is accepted. Cool. Thank God. This problem sucks. Okay, what is the time and space complexity? Time complexity. Well, we can see that we need to iterate over all of the strings in strings. So for a start, we're going to be doing n operations where n equals number of strings in strings. Okay, but inside of the loop, what are we doing? Well, in the worst case, we're going to have to go over every single character of our string. So let's just say it's n times k, where k is the length of the longest string in strings. In the worst case, they're all going to be of length k. So we're going to have to n times process n characters. So that is why our time complexity is big O of n times k. For the space complexity, it's going to be the same thing. We have this grouping dict, which we'll have to store all of them. But because, actually, no, hold on. I think actually it's just n big O of n plus k. Let's see. Well, we definitely have the big O of n because we're storing each of these keys. And let's see. For each of the strings, we are creating a data. Okay, no, so it's n times k. So for each of the strings, we basically need to create this char diffs, and then we also need to basically cast it to a tuple. So it's also n times k because we have to create all those extra data structures for here. So that is the time and space complexity. Again, n is the same as in the above. So it's big O of n times k in the time, big O of n times k in the space. Like I said, this question is one where if you've seen the solution before, it's quite easy to kind of just explain it on a second time, but likely you are not going to come up with this. Maybe you did. Maybe you're super smart. Probably not. I mean, I definitely didn't get it the first time. I'll put my hand up, especially this modulo thing. I got screwed up on how to do the wraparound, and then I realized you just use modulo. Anyway, that is this problem. I don't like it, but whatever. Someone requested it, so I made the video. If you enjoyed the video, why not leave a like and a subscription to the channel? It really helps me grow. And I'll see you in the next one. Bye.